Hi, I'm Nicholas Thompson. I'm CEO of The Atlantic. And this is The Most Interesting Thing in AI, a podcast produced by Rethink, The Atlantic's creative marketing studio, in collaboration with PwC, a leader in helping organizations use AI. In each episode, we're exploring how artificial intelligence is reshaping our lives and redefining what's possible. There are critics of AI, and then there's today's guest, Gary Marcus. I once was with a group of prominent AI researchers, and I asked kind of flippantly, who is doing the most harm to AI? One of them said, Gary Marcus. And then the rest of them agreed. Gary is someone I've known for a long time. I edited some of his stories at Wired, and then I edited a lot of his writing on AI when I was at The New Yorker. He's a cognitive scientist, and he says he's actually an AI enthusiast, someone who really does think AI is going to change our world for the better. But he's also extremely concerned about where the industry is headed. And as much as Gary's made enemies in the world with his critique, his predictions of doom, sometimes his personal critiques of others, he has also been quite prescient about certain things, and there are folks in the industry who are now catching on. So I wanted to know what Gary's biggest concerns are about where the AI industry is right now. And I also wanted to know, is there another way forward? Is there a way we can make AI more inclusive, less polarizing, while also making it function better? Gary has answers to those things and then some. As you'll hear, Gary loves to spar, and we get into it a bit at times. So I hope you enjoyed listening to this conversation as much as I enjoyed having it. So Gary, you are one of the most prominent critics of AI. But you've also said that you genuinely love AI. So let's start there. What is the beginning of your love story with AI?
So I was 10, and I learned how to use a paper computer. Paper computer is, you could say it's a simulation of a computer. It has registers. You write things down. You're going to store something here. And you could do operations. So you could multiply things, add things. The outputs go in one place. You compare them. If you look at the assembly language, or really the machine language of a computer, it's basically just doing the same stuff as that paper computer, which is to say that I learned to program that day when I was 10 years old at this after-school program that I did at Johns Hopkins University through my school. And as soon as I understood how it worked, I was like, well, what else can you program? And that led me to be interested in AI immediately.
You began to write a great deal about AI, I believe, when I was at The New Yorker, and you were writing pieces that I was editing back there.
When I started writing with you, IBM Watson had won at Jeopardy, which surprised me. I think one of the first pieces I did for you was actually a critique of Ray Kurzweil's How to Create a Mind, which was kind of on the edge between neuroscience and AI. Deep learning was starting to get popular, and that brought me back into the field.
So I remember I was with you November 30th, 2022, when ChatGPT was launched. We were at a conference together in Arizona, and I remember you pointing out some of the flaws in ChatGPT and some of the responses.
I thought, hey, people are being fooled. This thing is very anthropomorphic, but it's not really that smart, and it's going to have problems. And I knew what the problems were because I had written them for you in 2012 and for MIT Press in 2001. They were new models. They were a little bit different. But the core problems hadn't really changed. And so I knew it was going to make dumb mistakes. It was going to hallucinate, et cetera.
I went back and I read your tweets from that first day. That first night, you tweeted the screenshot of a wonderful query to ChatGPT where somebody said, how long does it take to bicycle from San Francisco to Maui? And it responded, well, I don't really know how. It depends like how fit the cyclist is and the kind of bike they have. A very funny response. I put that query into ChatGPT today. Its answer was actually amazing. The answer was, well, there's no land bridge, so you can't actually bicycle. If you wanted to bicycle, you would have to build some kind of floating contraption and put a bicycle on it, in which case it's 2,400 miles. And if you bicycled through the day and night, this is how long it would take. But you also probably need to sleep, and there are probably going to be waves. Once you get to Maui, this is how long it takes to get around the island. So we're getting better at this problem of hallucinations, right?
Well, yes and no. There are still hallucinations. Every time I put something popular that, goes viral on social media, I think they fix it. I've been told that they train on the popular things. They have, a team of who knows how large dealing with my observations, other people's observations. So what I have found is that if you take an error that I reported on, it often gets it right. And then if you change it a little bit, it often gets it wrong. And so that speaks to the superficiality, I think, of what is learned and also how these systems are patched.
I want to talk to you about why you think AI makes so many errors, which I think gets at the core of both some of your concerns about it, but also some really interesting scientific debates underneath it. So let's go back. In March of 2022, you wrote a piece for Nautilus. It's called Deep Learning is Hitting a Wall. And you posed the question, what would it take for artificial intelligence to make real progress? Why don't you walk me through the central argument of that piece and what you would revise about it now?
What I should have said is scaling is not going to last forever. And there are some fundamental problems with deep learning. They're not going to be solved by taking the current approaches.
Yeah, that's a great title. That works really beautifully on a magazine page.
I know. It would look great on a magazine page. So the notion at that time was you could predict exactly how well a model would do as a function of how much data it had and how much compute it had. And people invested $500 billion assuming that that was true. And I said, it's not true. It's not going to go forever. And we got one really good exponential jump from there after I said that, but not two, and not three, and not seven.
So scaling laws are the idea popularized by many of the most important people in AI that the best way to improve a model is not to teach it a whole bunch of rules and not to embed a whole bunch of symbolic logic, but just to power it with bigger computers and add more data. And this has been one of the big debates or tensions in AI since the 1960s. And many people would argue that the folks arguing for scaling laws, just add more machines, those people would say this argument is correct and that it just happens. Maybe you wouldn't think it would happen, but the more data, the more compute, the better the models get. And in fact, that is what's powering this. You're arguing something different.
Two things. One is you said the most important. I would say the most popular people in AI, not necessarily the most important. Time may tell us that this is not the right approach at all. So you have many people pushing the scaling approach, but that may turn out to be wrong. So they're currently important. That doesn't mean that they're correct. In my view, which Jan LeCun, by the way, shares, is that this approach of large language models and scaling is not going to get us to AGI. AGI stands for Artificial General Intelligence, and it's been defined in several different ways, but basically it's the idea that you can take an AI and do whatever you want with it, that it can do almost anything roughly as well as humans or better. If Jan and I are correct, then these people sort of had a passing role on a detour.
These people, meaning Dario Amodei, is the CEO of Anthropic, Sam Altman of OpenAI, most of the people who run most of the big AI companies.
That's right. Maybe not Demis Hassabis, who I think has a more open-minded view than I think some of his other folks do.
Right, because DeepMind is a combination of both scaling laws and symbolic AI, which you're more of an advocate of.
Yeah, I'm going to just clarify. Scaling laws were a hypothesis. There was a hypothesis that those were like physical laws. I said, no, they're not. They're just empirical generalizations. They will hold for time. And what's interesting about the last several months is they stopped holding, if you really want to be honest about it. And I want to make one more thing precise, which is the scaling laws were mathematical laws with exponents. You could calculate things. It wasn't just, hey, things will keep getting better. It was that they would get better in a very precise way, predictable as a function of how much data. And that's why people put so much money into this. And what was interesting in November is that some very powerful people started acknowledging that. Satya Nadella at Ignite gave a talk that sounded exactly like what I had been saying in the deep learning is hitting a wall paper. Around the same time, Mark Andreessen said, we're not getting the advances that we predicted anymore.
So it's true that I don't think anybody, even Dario, wouldn't say a scaling law is a law. In fact, I think I've heard interviews where he calls it more the scaling hypothesis. Yeah. And what he would argue, I think, is, look, it's not a law. It may stop at some point. But every time we add more data, every time we add more compute, it gets better. And my experience as a user—
How much better actually matters a lot. I'm not going to concede that piece. So there was
You won't
there were
concede that it
laws.
gets better, or you won't concede that if you...
It does get better, but we've reached a point of diminishing returns. I think the empirical data are very clear on that. One of the things, I made a whole series of predictions last year, and one of them was that we wouldn't see GPT-5 in 2024. And that was a very heretical prediction. There were all these people saying like, oh, it's going to drop after the Super Bowl. And this was in February of 2024. We haven't gotten to GPT-5. Pure scaling does not work anymore. You no longer come out where you would have before. Grok 3 was 10 times, I think, the size of Grok 2. It's a little bit better. There was a project called Orion, this has been reported, which was supposed to be GPT-5. It was so disappointing that they called it GPT-4.5, right? So they put in what they thought would get us to what people thought would be a GPT-5 level model, and it wasn't that. In fact, they have like 20 models now, like Chat GPT 4.0 Mini High is the name of an actual model. And the reason that they're doing all of that nonsense is because nothing is actually coming out where they thought it would with this law. GPT-2 versus GPT-1, which was just called GPT, was a revolution. GPT-3 relative to GPT-2 was a revolution. GPT-4 relative to GPT-3 was a revolution. GPT-4.5 relative to GPT-4 is like, yeah, it's better. Some specific cases you want are better. But it's not a quantum leap. We're not getting the quantum leaps anymore.
I use different AI models to help me with research for a book I'm writing. And I feel like every 3 to 6 months, maybe every 3 months, there's just something clearly better. The notes that I've taken from interviews and then read text that I've written and analyze where information from those notes could improve the text that I've written, or quotes that have been given to me by people I've interviewed that are better than the ones I've included in the text. And to do that requires a pretty sophisticated understanding of what's in the text, what the person said, what kind of style I'm looking for.
I'm going to take for granted that what you said is true. But, I mean, 4 was not just better than 3. It was qualitatively better. It was like night and day. The excitement came when 4 blew away 3 and 3 blew away 2. That's when the excitement came. We have not had another moment like that. Do you know how many shots have been on that goal? Right? If all it was I need more data, I need more compute, everybody had the recipe. And in fact, everybody took a shot on that goal. And everybody is Google, it's Meta, it's OpenAI, it's Grok, it's, I guess, Alibaba, it's DeepSeek. None of them succeeded in the thing that they would want to call GPT-5. There's enormous economic reason for somebody to do that, but they also have to be careful about it, right? So if OpenAI says, aha, this is GPT-5, then people try it out, and it still makes boneheaded errors, it still hallucinates, the kinds of things I pointed out in the 2022 paper, then people are going to be like, yeah, that's disappointing.
Do you believe that in 3 years, OpenAI and Anthropic will still be viable businesses?
Are they viable businesses now? I don't know that OpenAI will ever earn out the valuation that it has. I think that they have serious financial problems right now. They're burning, I think it's about $500 million a month, which is a lot of money. They can't keep doubling the valuation. At some point, somebody's going to be like, I'm not going there. A lot of people think that they might get the next round from Saudi Arabia. After that, it's just not clear. They need to stand on their own feet at some point, and because they're burning so much money, that's a problem. They've lost a ton of really good talent. They're making more and more money, but they're making like $3 or $4 billion a year, but they're spending, double, triple that. They don't have a moat, right? Everybody knows how to build what they're doing. So more people use them than anything else. That's the best thing they have going, but they don't have a technical moat. DeepSeek, for example, can catch up and charge less money. That's a problem, right? So there is a price war. That was also in my list of 2024 predictions, that there would be price wars, there'd be no moat, and that's where we are. OpenAI could still succeed. I think that they're going to become more of a surveillance company. They may just be sort of like Facebook.
Wait. What do you mean a surveillance company?
Basically, they're collecting a lot of very private data, and even if they can't solve AGI, which I think they probably can't, or at least not with the techniques that they're using now, they can still sell that data. And some of it's very, very private. So they can do, micro-targeting of ads, or they can sell that data to other people who want to do micro-targeting of ads. I think that's the direction that they're headed. I thought that before they announced that they want to build their own social media company. Either they build a technology that nobody else has, they beat people on price, Or they sell surveillance. What are the other options? I mean, obviously, they're looking at government contracts.
I mean, I think what they would say about their economics is they're going to create intelligence in a box that is so valuable it would create immense wealth. And if you can get any cut of it, I mean, it's the classic model of Silicon Valley. You create something.
The problem is that their approach to that is the same as everybody else's in Silicon Valley. And everything that they do gets replicated quickly.
We were talking earlier about your belief not only that scaling laws are not laws, but that they are asymptotically slowing down and money being invested into scaling AI systems is no longer as efficient. In your view, there's a better way, neurosymbolic AI. Explain what that is and why that would work.
If you go back to the history of AI, there's always been two approaches. They're actually a little bit reminiscent of Kahneman's System 1 and System 2. So neural networks, which have been around since the 40s, are ways of learning statistical generalizations about the world. The other approach, which really goes back to Russell and logicians, much earlier, is AI that looks more like computer programming. It's abstract, it's symbolic, has representations of explicit knowledge, and we do some things that way. So GPS navigation systems are purely symbolic. But probably the right answer is to bring these things together because neither of them works that well on their own. I've sometimes joked that in the 80s, we had symbolic expert systems, and they didn't work that well. So we paid graduate students to fix the problems. And now we have big neural networks, and we pay people in Kenya to fix the problems. Neither of the systems are that robust or that reliable.
So what would it mean to add symbolic logic to a currently constructed neural network?
It's not clear it can be done as such. We may need to find new tricks, but you want to be able to take whatever knowledge you can acquire from a neural network and be able to reason over it symbolically. Now, the problem is that neural networks are really just tracking statistics of how words are used together. They don't have abstract underlying concepts. So one possibility is to extract those abstract underlying concepts and send them off to a symbolic system. Another is to take information from the symbolic system to try to affect the neural networks. There may be some other ideas.
So how would you do that, right? If Ilya came to you, Ilya Sutskever, one of the founders of OpenAI, who left, he started a new company, and he came to you and said, you know what? My idea is we're going to build symbolic logic and we're going to combine it with the best of deep learning as currently constructed. Gary, here's $100 billion or $10 billion. How would you do this?
I have thoughts about how I might want to do that I don't necessarily want to share. But step one is you need neurosymbolic AI. You must have a way of going back and forth between the information that you acquire statistically in neural networks and information that is represented symbolically. You must have abstract common sense knowledge about how the world works. And LLMs kind of fake that, but they don't fake it well enough. So you have to have a model of the things in the world. So like right now, we're in a room, there are microphones, we're both human beings, there are headsets, there are monitors. We both understand the entities that are in the room, and we can make predictions around them. We can make predictions about how each other might react. What if we heard that there was a fire? Would we feel obligated to finish the conversation, or would we leave the room? So we have these models of the world. And then we have reasoning abilities. No AI really has reasoning as good as humans are in certain kinds of cases, like when we have partial and incomplete information. We have very good symbolic tools. We have full information about what's going on in the world. But humans are pretty good at making good guesses from small amounts of information.
Wait, so why is this a symbolic knowledge problem and not just a data problem, right? If you fed, as Jan LeCun has tried to do, feed an AI model videos, right, of all of these rooms. So you can learn, right? You can learn that when I drop the pen drops, or you release the pen, which is something AI models had trouble with at the very beginning. And you don't have to type in every time pen is dropped, gravity affects it. You just have enough video of pens dropping that you figure it out.
In general, what has happened is that things are not robust enough. So systems learn particular cases, but they don't generalize them very well. That actually goes back to 1998. I made a distinction, basically. I said you can generalize to things that are nearby in what I called a training space pretty well with these kinds of architectures. You could call that interpolation, but they don't extrapolate well to things that are far enough away. And you can see this, for example, in Sora. What you see in Sora is these weird things, like you'll have 3 people go behind a wall and then 2 people come out, or 4 people come out. And you see things like people turning into dogs and stuff like that are not what we'd actually expect in the world. And so if you look carefully at the videos that they produce, every pair of frames makes sense. The second frame always makes sense relative to the first frame, the third from the second, the fourth from the third. But if you look at the first frame and the 27th frame, let's say, you can get completely bizarre things. There's a developmental psychologist, Elizabeth Spelke, at Harvard, has talked about why we might have innate underpinnings for some of this stuff, for recognizing that there are objects in the world, that they persist in time, and so forth. And all of these systems are basically blank slates. Chomsky's major idea, in some sense, was that there was an innate language acquisition device that constrained how we could learn about language, what we could learn for language. And I think there's something similar for how we learn about objects and so forth. Spelke has a quote I can't quite do from memory, but I've quoted many times, saying, if a child is endowed with objects, persons, sets, places, maybe events and so forth, if you start with those kinds of things, then you can kind of understand the rest of the world in terms of those. But if you just understand the world in terms of pixels, which is what current neural networks basically do to a first approximation, it becomes very hard to induce the right level of abstraction.
So this is very interesting. There are two tracks, right? There is a track that tries to do neurosymbolic AI, right? And you have systems. IBM Watson, right, has lots of neurosymbolic AI built into it. Amazon's Alexa. These things, but they don't work as well. The argument that many folks in AI would make is they don't work well because the whole thing was flawed. As the famous quote goes, every time I fire a linguist, my model gets better. Your argument, if I'm understanding correctly, would be it's just that that other approach got all the money. If you'd put all of that money into neurosymbolic AI, you might have something even better, or at least you'd be on track for something better in the long run.
I think if we put in $500 billion into neurosymbolic AI, we'd be very far ahead of where we are now. People talk about algorithmic progress. The algorithms haven't actually gotten better. We're still using transformers. Basically, people tested one hypothesis, which was more. They saw how it went. It's gotten something, but it has not, I think, answered the deep questions that I keep raising. I think if we had put that kind of money in neurosymbolic AI, we might know a whole lot more now about how to build AI. I don't think any science, great science anyway, has come out of this sort of chatbot enterprise. You know, it helps write papers and stuff like that, but I don't think there's anything as important as AlphaFold has come out of it.
AlphaFold's a super interesting example because I've often said that to me, the greatest error in AI, or the thing that has been worse for the world, has been the headlong pursuit of AGI. And that making AI that is like humans has some good things, but it is also where all the bad things come. And making AI for really good tools like AlphaFold, you really only get good things. So when you go for AGI, you get good things and bad things. When you go for tools, you get mostly good things.
Mostly. There's an asterisk around that, but mostly correct.
Sure. Is this related to the symbolic versus scaling law debate? Are those things related, or are they just kind of parallel and similar?
There's a bunch of separable things, but they kind of travel together, I guess. In principle, you can build your AI to do different kinds of things. You can have different values in terms of the people who are operating the companies and what they want to do. It so happens that the people who have built AI around big data are in companies that either are or may soon be involved in surveillance and have made, I think, dodgy choices sociologically, ethically, and so forth. The symbolic versus scaling is not quite a dichotomy. I mean, I think one of the places where all of this connects deeply is that the scaling of transformers, which is what people are doing, doesn't give you interpretable models. So you can't look at one of these models and know exactly why it's doing what it's doing. That's different, let's say, from a GPS navigation system where you can say, this is the algorithm, this is the data, this is how it gets to the answer. If it makes a mistake, you can debug it. It never says, oh, and by the way, let me blow up a building. Like that's not something it does. Whereas we have these black boxes, these chatbots, we don't really know why they produce the answers that they do. We basically have to run them in order to find the answer. We have no formal proofs about what they would do under certain circumstances, no formal verification. They're a mess.
I agree. Interpretability, probably the biggest problem in AI, certainly one of the biggest problems.
This is something Dario and I agree on. The difference between him and me is he thinks we're going to get to interpretability through scaling. I think that's a fantasy.
The other difference between him and you is he's probably made $50 billion for himself on scaling AI, but let's leave that aside for a second.
Leave that aside.
So the problem with scaling transformers is that you don't get interpretability. If you don't have interpretability, you have all kinds of problems because you don't have control in the way that you would have if you had a symbolic system. So therefore, in a way, what you're arguing is that scaling transformers has kind of necessarily set you on a path where you will have all kinds of problems in a way that symbolic AI would not.
So far it has. On any particular question you ask,
symbolic AI could have bias problems.
It could, but they can be more tractable. You can figure out what's going on. I mean, bias problems are not trivial. They don't just magically go away. I'll give you one example. If you try to assign people jobs based on their background in a neural network, you have basically no idea why it happens, and you can't put a constraint like, I would like equal representation. In principle, in a symbolic system, you can put in a constraint. You can say, I would like equal representation or something like that. Large-scale machine learning systems of the sort that we know how to build do is essentially they perpetuate past history. So, for example, if you find that very few ballet dancers have been computer programmers, the system may push you in that direction, even though the reality is very few ballet dancers became computer programmers because of a set of cultural norms that we might actually want to change. If you can symbolically specify what you want, which is what the equal opportunity laws of the United States do, then you can try to push towards an outcome that is not represented in the past data, but that you would like to achieve.
How do you possibly put in enough symbolic knowledge? Like, I can understand it for a very simple thing. You're trying to understand our interactions in this room. Okay, so gravity works, sound, and the walls. Like, I can imagine 1,000 people at 1,000 computers writing down all the rooms. You lift the cup, you put the cup down, the water burns like this, there's gravity, you drink it, it has this to your voice, and so on. But the rules of the world, how on earth could symbolic AI have enough rules?
So I guess there's a couple of things to say there. One is there was one effort, and only one effort, to try to do that at scale, which was Doug Lennett's Psych system. It's sort of limped along. It has not changed the world, but they've tried to formalize a lot of knowledge. The second thing to say is they did that based on technology they developed in the 1980s. I think we could do it in a better way if we tried now. The third thing to say is it felt like an expensive project at the time, but it was really like a couple $100 million. So like a couple $100 million has gone into that mission, whereas $500 billion has gone into let's just scale all the data. And so it's a very disproportionate amount of money has been invested into these two approaches.
But if you have two approaches to solving a problem, and one is we'll hire 1 million people and they'll all work nonstop and we'll try to come up with a set of rules. And the other is like we'll read the whole internet, we'll put it in a blender, we'll stir it 2 times and we'll have 3 people do it. It's just so much cheaper.
It's so much more seductive. But the reality is even on that latter approach, now they are hiring 1 million people. So all of these companies are actually hiring people to patch up all the problems. I alluded to this before. That's why, for example, OpenAI was hiring these Kenyans to do reinforcement learning about how to respond to a user. And now, like, mathematicians are getting paid $100 an hour to write proof examples.
But then isn't that just kind of working in the same direction, right?
Yeah, but it's very half-baked is the polite way to say it.
But if I hire 1 million people and we're trying to write up all the rules for the world and we're trying to explain exactly what happens, tons of biases are going to get in there.
There's lots of problems there. And I should say the reason I want something that's neurosymbolic is neither approach has worked on its own. So the neural network approach, the knowledge is never systematic enough. I like to call it pointillistic, and Ethan Mollick talks about a jagged frontier. It's basically the same notion that, like, it's just not that systematic. But we want what is learned to be abstract and generalizable in the ways that it is in symbolic systems. That's what we need to get.
Do you want the world to get to AGI?
That is a very interesting question. I don't want the world to get to AGI if it's going to be half-baked in the way that large language models are. If we had a kind of AGI that was just unwieldy and untractable, we never knew what it was going to do, that would be really dangerous. If we had a tractable version of AI that was verifiable, is to help with science and medicine and discovery and so forth. But if we're going to do it with these black boxes, it doesn't look good to me.
What to you is the worst plausible outcome of the next 3 years in AI?
That we rely more and more on these problematic tools, and that many people die as a result of, for example, military applications where the technology is not really very good and it's just a fig leaf to cover immoral decisions in the first place. So, we have machines doing it, And it sort of displaces some of the blame from the important part, which is how many people are you willing to sacrifice in order to achieve your military objectives.
Your fear about AI in the military is not it'll unleash drones, there'll be an accidental nuclear launch. Your principal fear is that it will make more efficient killing machines and, even worse, give people an excuse to kind of let them loose in a way they want to but know they can't morally justify?
I mean, it's really two things. One is some of the decisions are going to be bad. Now imagine that you take an LLM and have it decide military strategy. You know, the thing that LLMs are worst at is dealing with unknown, like fog of war. When you have a new military situation, you don't have any data. That's a terrible place to put an LLM. Like, what they're best at are things that they've seen before, that are in the circumstances they've seen before. But because military technology is constantly changing, they're not very good at that. So there'll be some bad decisions. That's part one. And part two is that unethical decisions, whether correct or not, will be justified by saying, oh, well, the AI made me do it.
That's super interesting. Let me run my biggest fear by you. So my biggest fear is that either existing social media companies or social media companies of the future will develop some like Westworld that you get into and you start talking to people online and maybe you fall in love with them and maybe you talk to them infinitely, and that a large portion of humanity will be sucked into kind of fake relationships with human-seeming bots online.
That game is on. I mean, that's definitely happening. I mean, it's hard to even rank like killing 100,000 civilians or having an accidental nuclear war versus that stuff.
But if there's ever a time to rank them, it's right now on the podcast, Gary. So give me your top 7 dystopian outcomes for AI.
Top 7, man. One is that tech oligarchs will take over Washington, D.C., and we will wind up with a totalitarian government. That was what I wrote about in my last book, and you can evaluate how correct that prediction was for yourself. Misinformation, I think, is going to continue to contribute to an environment where democracy cannot really flourish, because you cannot be an informed voter if you cannot distinguish truth from falsehood. And if you are surrounded by a sea of machine-generated falsehood, you can't be an informed voter, or at least it becomes much more difficult. And so I think democracy is in serious trouble. I do think we could get an accidental nuclear war, in part governed by misinformation. People might use misinformation to drive the stock market. They might, for example, want to short the market, like put out a lot of information that makes people think that something is really bad. That in turn might escalate into a nuclear war.
So the second one you mentioned, the misinformation one, absolutely true, right? Democracy might fail because of AI, and it does seem that technology in general has helped authoritarians more than Democrats. But it doesn't have to be that way, right? And if you look at, for example, Taiwan, right, public information systems, ways of giving feedback to politicians, not necessarily using AI, but using experts and incorporating AI, you can imagine AI leading to a much more informed and much more empathetic citizenry. How do we get there?
This is a very good question. I think it has to start with values and with a citizenry that wants that and demands that, to say we want an AI that works for us. There is still a chance, though I think the chance has fallen, of having AI have a very good outcome for democracy, for science, et cetera. But the default in the United States, the way things are set up right now, is that the oligarchs are making the rules to favor themselves, and they're not really interested in other people. So unless people take to the streets and say, we want this stuff to work for us, it's just not that likely that'll happen.
After the break, I asked Gary about some bets he's made on the future of AI. How right is he? We'll find out. The most interesting thing in AI. We'll be right back. I want to go back to a bet you made in May of 2022. You challenged Elon Musk, $100,000 bet, about where AI would be in 2029. So I'm going to read their 5 predictions. I'm going to ask you whether you think we're going to get there. So will AI be able to watch a movie and tell you accurately what is going on in it?
Maybe. I mean, a bunch of people...
Seems like we're getting there.
A bunch of people would say we're getting there. One thing I should have specified more is like it has to be a movie you haven't seen before. Obviously, it's not interesting if someone's already put the plot summary.
Right.
What we find now is they write things that sound convincing, and then you check the facts and they're not that great. I remember a year ago somebody saying basically they had done what I described there, and I got nervous, like have I gotten it wrong? And they said what they had done is they fed in Mr. Beast video and out to, I think it was one of the Google models. And out came this kind of chapter-by-chapter summary. But then I looked in the comments. I don't watch Mr. Beast videos, so I couldn't judge for myself. But someone else who did said, there's an error here, there's an error here, there's an error there. So like the guy who posted it was so excited that it did it. Yeah. And then someone looked, and it's like there's a lot of errors.
So that one we're going to say questionable. Will AI be able to read a novel and reliably answer questions about it? It can totally do that now.
But with the same problem. If you ask reasonably subtle questions of a new novel that is not in there, it's going to make some mistakes. I promise you.
I don't know. I think it's basically there.
There are many wealthy people who would like to rub my nose in it.
100%.
It wouldn't be that expensive for them to try it. So, bring it.
Piece of cake. That one's going to be done. You're going to lose that one. The next one you're going to win. Will an AI be able to work as a competent cook in an arbitrary kitchen in 2029? No chance.
Now, that's a question of the intelligence behind robotics, right? We know that through teleoperation, an Optimus robot is now good enough to work in a kitchen, basically.
Yeah, but teleoperation is a cheat.
And that's why you need AI. And so can the part that the teleoperator does be replaced by AI by 2029?
Oh, so you have an AI teleoperator operating the robot.
Yeah. So I'm saying the physical part, I mean, it's not easy, but the physical part.
I don't think the physical part is going to work either. Like, Gary, take the W here, dude.
I'm taking the W.
I gave you an L on the last one.
Yeah, you're wrong on that, but I'm taking the W. Let's move on.
Will an AI be able to reliably construct bug-free code of more than 10,000 lines?
There's a proviso in there, Rich, is it can't be just from a library and so forth.
Sure, but it's going to be able to do that.
I mean, there was the Kevin Roose thing about vibe coding, and he did this little thing where you take a picture and it's in your refrigerator and makes a recipe. That code was already out there, number one. And number two, the system doesn't really work that well. Somebody else went and did Pac-Man. They just asked 7 people to vibe code Pac-Man, and none of them worked, right? So 10,000 lines is a fair amount of code and bug-free. And there was just a study showing that coding is not so bad. Debugging is really bad. If you want 10,000 lines, you got to be debugging.
I mean, if we define this one super narrowly and it has to reliably, meaning always, have 0 bugs and 10,000 lines, I don't know. I think I'm giving you the L on this one.
I think it just sounded like you're giving me the W. If it has to be the thing that I said, which is bug-free 10,000 lines of code, then you're like,
not the way I'm reading it. Will an AI be able to take arbitrary proofs from the mathematical literature and convert them into a symbolic form suitable for verification in 2029?
I mean, I have a side bet with Christian Szegedy on that particular one. That one's still open. The one thing I didn't specify in that post was it has to be one system that's doing most of them, right? Because AGI is general intelligence, right? So if somebody builds a theorem-proving system that can't do anything in a kitchen and somebody else builds a kitchen system that can't do theorems and so forth, that doesn't count as artificial general intelligence. And there's some wiggle room. People could have interesting conversations around it. I still think I'm going to win the bet. I mean, we'll see. Also, let's note that Musk didn't take the bet. I offered him to bet, and he never responded. And then I upped it to $1 million with slightly different criteria over 2025. So last year he said by the end of 2025, we'd have machines smarter than, I won't get the exact wording, which actually matters, but smarter than any human. So I offered $1 million on that. A friend offered up at the $10 million. We would have clearly won that one. We're not going to have that level of intelligence by the end of this year.
If you're making bets based on Musk's most egregious Twitter predictions, I think you have a reliable source of income. Speaking of the future, I want to ask you a bit about driverless cars. I know you didn't work directly on the driverless car projects at Uber, but for a time you were their head of AI, right?
I helped launch Uber AI Labs. I was there just for a few months.
Do you think that the model that Waymo has built is going to be able to scale out beyond San Francisco and a number of small cities and areas where there aren't snowstorms?
Ever? Yeah, probably. There's 2 fundamentally different approaches, right? Tesla is trying to do everything from cameras and trying to do things without very detailed maps of individual cities. Although I do note that they're pre-mapping Austin by having a bunch of drivers before they go online. So I don't fully know what Tesla is doing. But their first approximation, they don't use LiDAR, they just use cameras, and they're trying to build something that, if it works, can work anywhere. Waymo is trying to build very detailed maps of each city that it drives in. And my guesstimate is it's spending more than $1 billion per city, probably much more than that. And that they extend beyond, from what I've heard, but I can't prove it, but stuff I've heard kind of in the gossip mill, it extends beyond just Google Maps level stuff. It's much more detailed. It probably includes not just sort of cartographic stuff, but also cognitive stuff, like when does a tram run here and stuff like that. So to scale to other cities, first of all, it's expensive. It takes them a long time. Like they've announced DC a year in advance. They can't just say, hey, we're going to plop this down somewhere else. Actually, when I worked in Uber, we had a big party to announce that my company was going to be sold to Uber. And they set up in one night, I think, an instance of their system in Barcelona. It just took a night. Whereas it will take like a year to set up each new city at the moment.
But in a way, this is kind of interesting, and I hadn't realized this when I started asking this question, but the difference between Waymo and Tesla is a little bit the difference between the symbolic AI approach that you've been advocating during this conversation and the scaling law approach. Like Tesla's approach, just get a lot of data, drive the cars around, go as quick as possible. Yeah. And Waymo's approach is let's build maps of everything. Let's get the time schedule for the trams. Let's build a detailed map of San Francisco. The problem with the symbolic system is it's really expensive. The problem with the scaling law system is the cars crash in airplanes.
Yeah, I mean, the first approximation, that's right. A lot of it's proprietary here. So some of what I can say, I'm just guessing, I don't know for a fact, but my understanding is basically Tesla has moved to a giant neural network with a lot of data. And so it's very much in keeping with the people who are pursuing the scaling hypothesis. Whereas Waymo, I think, has a lot of classic symbolic rules in there to deal with things like Stephen Levy wrote back in 2015, to deal with things like leaves. So I think they wrote some symbolic rules for like, how do you recognize whether there's some leaves on the ground so you don't stop short for no good reason.
All right. Let me ask you a final question. It's a question I ask all of our guests. What would it take to convince you that AI is sentient or self-aware?
I think it would have to work on different principles than an LLM. I think when an LLM tells you something that appears to be sentient, it's just mimicking human data. Like if it tells you I like to play with my friends and family, it doesn't even have friends and family. You want a system that has some stable model of the world that reflects reality in some way, at least as a prerequisite. I mean, there's David Chalmers stuff about the hard problem of consciousness, and I don't think anybody really understands what consciousness is, so it's hard to answer that question. But sentience is not the same thing as intelligence. Systems might get more intelligent without being any more sentient at all. And sentience is about being aware of oneself in the universe. My Apple Watch is like a little bit that. An LLM isn't that at all.
All right. So we'll end with that. Gary Marcus's Apple Watch, sentient. AI, not.
That's not quite what I said.
All right. Thank you very much, Gary Marcus. This has been The Most Interesting Thing in AI. I'm Nicholas Thompson. If you've enjoyed what you've heard, please rate and review it on the podcast platform of your choice. And also make sure to hit the follow button so you can hear future episodes. Next week, I sit down with Audrey Tong. A friend of mine once described her as the smartest good person on earth. We talk about the ways that technology can actually strengthen democracy. Thanks for listening.